All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for this factoring, we're going to take this 9 and multiply it by the 25 to remove it. And so we're going to have x squared minus 30x plus 225. The two numbers that you're going to want to use are going to be negative 15 and negative 15. So you're going to have 9x minus 15 times 9x minus 15. Both of those will reduce by a 3. And so you'll have 3x minus 5 times 3x minus 5, which you can write as 3x minus 5 squared. And so that would be your answer for the factoring. For the math knowledge question, we are given a right triangle and we want to use a trig ratio. On this one, we have the adjacent and the opposite. So we're going to want to use the tangent function. The tangent of 20 degrees is opposite over adjacent. Remember, that's one that you're supposed to memorize. If you haven't done that, you need to make sure to memorize those. Okay, so now to solve for our b, we're going to multiply both sides by b, and we'll have b tangent of 20 degrees equals 3, and then you're going to divide by the tangent of 20. But if you look, that's not actually one of the answers that they give us. So now what we need to try, we need to figure out what this angle right here is. And it is 70 degrees because these two are complementary angles. And so now we're going to try and say the tangent of 70 degrees. Well, the tangent is still opposite over adjacent. So we're going to do b over 3. So if you multiply by 3, you have 3 tangent of 70 equals b. And that is an option, that is E. So the correct answer would be E there. So we're looking at lesson 70 today. We're looking at finding surface areas and volumes of pyramids. So hopefully after this lesson, you'll understand how to find the surface area and the volume for pyramids. So first off, we're going to look at some of the terms that go with pyramids. The vertex of a pyramid is the common vertex of the pyramid's lateral faces. The vertex is at the very top, and it's the one vertex that all of the lateral faces have in common. The base of a pyramid is the face of your pyramid that is opposite the vertex. So whichever face is opposite the vertex, that is the base for your pyramid. A regular pyramid is a pyramid with a regular polygon for the base, and then all of the lateral faces are congruent isosceles triangles. So you can have a triangle for your base, you could have a square, you could have a pentagon, you could have a hexagon, you could have any number of sides for the base, but it just has to be a regular polygon. And then all of your lateral faces have to be congruent isosceles triangles. And if that's the case, then you have a regular pyramid. The slant height of a regular pyramid is the distance from the vertex to the midpoint of the edge of a base. So this is our vertex here, and the slant height is actually on your face right here. It's that little dotted line that they drew. Now, the height of your pyramid is different than the slant height. For the height, it's going to start here, and it's going to go down into the middle of your base. So that line that I drew in is the height, and this over here is the slant height. Those are two different things. The slant height is always going to be longer than the height of the pyramid. This would be the side of the pyramid, and this would be going straight from the top to the bottom. Okay, so the slant height is always the distance from the vertex to the midpoint of the edge of a base, and it's going to be longer than the actual height from the vertex to the base. The lateral area for regular pyramids is 1/2 PL. This P is perimeter, and the L is the slant height. Okay, so P is the perimeter and L is the slant height. That's the lateral area for regular pyramids. So we want to find the lateral area of this regular hexagonal pyramid. So in order to find the lateral area, the lateral surface area formula is 1/2 PL. So the perimeter. On this figure, we have a hexagon for the base. So that means that it has 6 sides. And you can even count them if you want. 1, 2, 3, 4, 5, 6. And each of them is 3. So the perimeter is going to be 18. Then the slant height, they tell us, is 9. That's what this number right here is. They drew it in for you. That's the slant height. It did not go to the center. If it had gone to here and it had gone up this way, that would have been the height of the pyramid. They gave us a slant height because it goes down to the side over here of your base. So we have 1/2 of 18 is 9 times 9, 81 inches squared, because we are dealing with area. And so that's the lateral area for that pyramid. For total surface area, you take the lateral area and you add the base. So you just take your lateral area formula, you figure that out, and then you add the base area, and that's your total surface area. So we want to calculate the total surface area of a regular hexagonal pyramid with a slant height of 11 and a base length of 5. So I'm going to start by writing my surface area formula. It's the lateral area plus the base. Well, our lateral surface area formula is 1/2 P times L. And then the area formula for base, well, we've got a base that's a hexagon. So we can use 1/2 P times the apothem, perimeter times the apothem. So I'm going to draw a hexagon. Using the computer real quickly. And so now we know that one of the bases is, each side length is 5 of the base, and so we can draw in our triangle. Now remember, we split this in half here and make a right triangle where this is a 30-degree angle, this one is a 60, and then this side length right here is going to be cut in half to make this a 2.5. That means that this side length here is going to be 2.5 square roots of 3. And then this one here is going to be 5. We're using our 30, 60, 90 triangle. If this is the 60-degree angle and this is the 30-degree angle, we have a square root of 3, a 1, and a 2. And so you can set up ratios if you would like, or we can take this 1 and multiply it by 2.5 to get to 2.5. So each side just gets multiplied by 2.5. So the square root of 3 times 2.5 is 2.5 square root of 3. And then 2 times 2.5 is 5. So now we're going to go back and use that information to fill in our formula. So our perimeter is going to be 30 because each side is 5 and there are 6 of them. The slant height they told us was 11. The perimeter again is 30, and we found the apothem to be 2.5 square roots of 3. Okay, so if you add those together, you're going to get 165, and then plus 15 times 2.5, and then times the square root of 3 is 64.95, and if you add those together, you get 229.95, and our units would be meters squared. Now on this one, it didn't tell us to round, so if you want, you can leave it as 165 plus some number with a square root of 3. And so if you really wanted to, you could say 15 times 2.5, get that number, and then write square root of 3 behind it, and then just have 165 plus that. I wouldn't do that just because it's going to give you a decimal, but if you want, you can do that. Okay, so looking at altitude of a pyramid, it's the perpendicular segment from the vertex to the plane that contains the base. So it goes from the vertex down to the base, and that's again different than the slant height. The altitude is always going to be smaller than the slant height. So your volume of your pyramid is 1/3 area of the base times the height. This height here is different than the slant height. This is not the same thing as L. Two different variables, two different numbers. So we want to find the volume of a tetrahedron with a base area of 4.8 square inches and a height of 2.5 inches. So you may not know what a tetrahedron is, but it is a pyramid with a triangular base where all of the faces are actually the same. We'll learn about it towards the end of the year. So this is our volume formula. 1/3 area of the base times the height. The area of the base is 4.8, and then the height is 2.5. And so then all you have to do is actually multiply that, and you end up getting 4 and then inches cubed. Okay? Looking at the next example, we have a stone pyramid found in an underground shopping mall in front of the Musée du Louvre. The structure is a square pyramid and has an approximate height of 3 feet, and its square base has sides that are 4.9 feet long. What is the lateral surface area of the smaller pyramid to the nearest square inch? So on this one, we're not looking for volume, so you don't want to find the volume. We're looking for the lateral surface area only. So our lateral surface area is 1/2 perimeter times the slant height. So it tells us we have a pyramid with a square base. And so I'm going to draw my pyramid as best I can. And so the perimeter of a square that has 4.9 feet long sides, you're just going to do 4.9 times 4. And so we're going to have 19.6. And then the lateral surface area. It is not going to be 3. The 3 is actually the height from the center up to the vertex. That is the number that is the 3. This right here. So what we actually have to do is to find the slant height, and that's going from the vertex down to the midpoint of a side. And so if you look, we actually have a right triangle here where this side length is 3. Okay, I'm going to draw that blue triangle a little bit bigger. The height is 3 here. That's what I just drew right here. The slant height is what we're going to be looking for. That's our L. So we don't know what that is. We have a right angle here. And then this number here, it's going from the center of the base to the side. And so this side length here is 4.9. So this part right here is half of 4.9. So just divide it by 2, and you get 2.45. And so that would be your 2 legs for your triangle. So to find your slant height, we're going to need to use Pythagorean theorem. So you're going to do 3 squared plus 2.45 squared equals L squared. So 2.45 times 2.45, and then add 9, and you get 15 0.0025 equals L squared. And you take the square root of both sides, and if you take the square root of that, you get that your L is 3.87. Okay, so that's how you would find your L, and then we're going to plug it into our formula. So our L is 3.87, and then we're going to multiply that times 19.6, and then divide it by 2. And you should get, if you round it to the nearest square foot, you're going to get 38 feet squared. It says round to the nearest square foot, so that's what you would round it to. Okay? I have 37.96 in my calculator, so that's why I rounded it to 38. Looking at the practice problems, y'all try these on your own, and then y'all unpause the video after everyone has attempted them, and I'll go over the answers. So the lateral surface area for the octagonal pyramid, that means that the base is an octagon. We're going to do the lateral surface area, 1/2 P times L, where the P is your perimeter, and so the perimeter, when we have a side length of 5 and we have 8 sides, that's going to be 40, and the slant height is going to be 7. So 1/2 of 40 is 20, and then times 7 is going to be 140, and our units are centimeters squared. For part B, what is the surface area? Well, for surface area, we do the lateral plus the base. And so our lateral is 1/2 PL plus 1/2 PA. And so our perimeter, we have a hexagon for the base, and the base lengths are 6. So that means that we have a perimeter of 24, because 4 times 6 is 24. The slant height they told us is 8. And so then I have plus 1/2, 24. And we've got to figure out what the apothem is. So again, I'm going to get the computer to draw a hexagon for me. And I'm going to draw my 30, 60, 90 triangle here. It's not such a great triangle. This angle here is 30. This one is 60. If the side length is 4, this half is 2. And so this is going to be 2 square roots of 3. And this is going to be 4. And so our apothem is the 2 square roots of 3. And so that's what you would fill in for your formula. And it says round to the nearest hundredth of a square inch. And so if you add all of that together, you should get 137.57, and it's going to be inches squared. Okay, so let's look at the next 2 practice problems. We want to find the volume of a square pyramid with side lengths of 5 and a height of 10. So our volume formula is 1/3 area of the base times the height. So the area of a square on this one is going to be 25. So we're going to have 1/3, 25, and then the height they told us is 10. So if you multiply that and then divide by 3, you're going to get 83.3 feet cubed, and it was to the nearest 10th, and so that's why we go to 1 decimal place there. Looking at the next one, we have a pyramid that is 321 feet tall, and the base length is about 600, and it wants to find the surface area. So our surface area formula is the lateral plus the area of the base. So our lateral surface area is 1/2 perimeter times the slant height plus 1/2. Actually, on this one we have a square, so we can just leave it as the area of the base. We don't have to use our 1/2 PL formula. Okay, so now we're going to do 1/2. The perimeter of our base, each side is 600, so multiply that by 4 and you get 2400. The slant height is 321. No, I'm sorry. That is actually the height. We're going to have to figure out the slant height. So we have a square for the base, and then we draw our pyramid. And we know that from the center up is 321. From the center to the side is going to be half of 600, so 300. And then we're looking for this slant height here. And so you're going to use Pythagorean theorem in order to find that. So you're going to have 321 squared plus 300 squared equals L squared. And so quickly use your calculator to figure that out. And so you should get about 439 for your L. That should be the number you get there. And then for the area of the base, you're going to do 600 times 600. So I'm just going to write 600 squared. And so now we're going to add those two numbers together. And so you should get 887,237. And it didn't tell us where to round. So if you want to leave it like that, you can, or you can put the 0.2 or the 0.18. It doesn't matter to me, but then your units are going to be feet squared. Okay, so that's how you would solve both of those. Now we're going to look at the challenge question. So y'all feel free to try this one, and then once y'all have tried it, if y'all think you have an answer, y'all can unpause the video and I'll go over it for you. So the volume of a tetrahedron, it's a pyramid whose base and sides are all equilateral triangles. We have an edge length of an S and a height of a 3/4 S. So the volume formula, we do 1/3 area of the base times the height. So we have an equilateral triangle for our base, and we've got S for each of the sides. But I'm going to split it into 1/2 S and 1/2 S here. And so this is a 60-degree angle, and so this is a 30-degree angle. And if this is 1/2 S and that's S, this side length here is going to be 1/2 S and then the square root of 3. So to find the area of that base, we can just do the area of a triangle. So 1/2, the length of the base is S, and then the height is this 1/2 S squared root of 3. So I have S and then 1/2 S squared root of 3. So that would be the area of the triangle for the base. And then the height, they tell us, is 3/4 S. Okay, so now we have 1/3 times 1/2 times 1/2, and that's going to be 1/12. And then I have S times S, so S squared, and then square root of 3. All of that gets multiplied by 3/4 S. So 1/12 times 3 over 4 is 3 over 48, which reduces to 1 over 16. And then we have s squared times s, which is s cubed. And then we have the square root of 3, which you can leave it like that if you want. I would probably write the square root of 3 over 16 s cubed. But that would be the volume for the tetrahedron that they give you. Okay, so make sure that you do your homework tonight. It is 1 through 30, and then we'll go over any questions that you have tomorrow.